Fascinating Frontiers, episode 146, coming to you on July 29th, 2026. Let's look at what's new across the frontiers of space and science. Astronomers may have found the first confirmed exomoon, and its size and orbit challenge every formation model we have. NASA scientists have flagged a strange object that may represent the first confirmed exomoon. The body's mass and separation from its host planet fall outside standard formation pathways for either moons or planets. Detection relied on repeated gravitational perturbations observed over multiple orbits. Confirmation would require additional transit or radial velocity data. Follow-up observations are already being scheduled with available facilities. The candidate exomoon stands out because its mass and separation from the host planet do not match either standard moon formation or planet formation pathways. Detection rests on repeated gravitational tugs measured across multiple orbits rather than a single transit event. If confirmed, the object would force revisions to models of how satellites assemble around gas giants or brown dwarfs. Follow-up observations with larger telescopes are already queued to search for additional orbital signatures. What formation channel could produce a body this large at such a distance? Copernicus Sentinel-1 radar observations captured up to 65 centimeters of surface displacement around Caracas after the recent earthquakes. The interferometric data from repeated orbital passes isolate those shifts at centimeter-level precision. Scientists are using the measurements to refine models of regional fault behavior. The results also feed directly into updated disaster assessment maps. Next steps include combining the satellite figures with ground-based surveys for higher resolution hazard products. The United States has announced plans to exempt private launch companies from several environmental regulations. Officials describe the change as a direct response to growing competition with China. The streamlined permitting timelines target testing and operations that currently stretch for months. Industry representatives have argued that existing rules delay each campaign by significant periods. Regulators are now defining the new review schedules that will apply. Satellite imagery shows the Great Atlantic Sargassum Belt reached near-record biomass levels in June 2026. Both the Caribbean Sea and the Gulf of America recorded all-time highs for floating seaweed coverage. The mat now stretches across thousands of kilometers and touches coastal ecosystems, fisheries, and tourism sectors. Researchers are merging optical and radar datasets to sharpen seasonal bloom forecasts. Continued tracking will help distinguish between nutrient runoff drivers and shifts in ocean circulation patterns. From one rare gravitational signature to another, we turn to a supermassive black hole caught in the act of shredding a star. A supermassive black hole encountered a star in a rare close passage, stretching the star into a stream of gas. Such events occur roughly once every 100,000 years in a typical galaxy. The disrupted material eventually forms a temporary accretion disk around the black hole. The process, called spaghettification, releases a brief but luminous flare. Astronomers are watching for similar transients in ongoing surveys to refine rate estimates. If the Sun were replaced by a supermassive black hole of a few million solar masses, a star on a close approach would feel tidal forces that differ by thousands of kilometers per second across its own diameter. The near side accelerates inward faster than the far side can follow, stretching the star into a long, thin stream of gas that swings around the black hole. Roughly 100,000 years pass between such encounters in a typical galaxy, yet each one briefly lights up the nucleus as the shredded material forms a temporary accretion disk. The resulting flare can outshine the entire galaxy for weeks before fading. We still do not know why some galaxies produce these events far more often than models predict. While one-off cosmic violence grabs headlines, steady orbital monitoring closer to home has hit an unexpected snag. The private spacecraft sent to reboost NASA's aging Swift telescope has developed its own attitude control fault. Preliminary checks show two of the vehicle's 3 reaction wheels are inoperable. The mission launched less than a month ago in a high-risk attempt to raise the observatory's orbit. Loss of attitude control could prevent the planned docking and thrust sequence. Engineers are assessing whether partial wheel authority remains usable. Hardware setbacks in low Earth orbit contrast with long-term planning for the next crewed-capable vehicle. Boeing continues to work with NASA on scheduling the next Central Standard Time 100 Starliner mission to the International Space Station. The flight would serve as a cargo demonstration while the vehicle remains in development for crewed operations. Engineers are reviewing propulsion and avionics data from prior test flights. No firm launch date has been set. The mission would mark the first Starliner visit to the station since the crewed test flight. While commercial vehicles sort out flight schedules, Europe is rethinking hardware originally built for a now-paused lunar station. The European Space Agency opened a call to examine repurposing the Lunar Link communication system as a standalone lunar orbit asset. The module was originally built for NASA's now-paused Gateway station. Engineers will assess power, thermal, and antenna performance in the new standalone configuration. A successful study could deliver an independent relay for future surface and orbital missions. Results are expected to guide the next phase of lunar communications architecture. New runs from the Illustris TNG project show that galaxy mergers do not reliably suppress star formation. The simulations follow gas inflows and black hole feedback through thousands of merger events. In many cases, star-forming gas remains available even after the galaxies have coalesced. These findings challenge earlier assumptions that merger-triggered quasars clear galactic gas reservoirs. Observers are now comparing the predictions against results from large galaxy surveys. Lunar infrastructure questions lead us to fresh data from the Moon's far side. New analysis of lunar material returned by China's Chang'e 6 mission is questioning the timing and intensity of the late heavy bombardment. The samples come from the Moon's far side and show different impact signatures than near-side collections. Researchers are comparing crater densities and isotopic ages to existing models. The data suggests the bombardment period may have been shorter or less intense than previously thought. Additional laboratory work on the samples is underway. A NASA executive noted that South Korea holds the technical capabilities required for contributions to a future lunar base. Existing Korean work in robotics, communications, and life support systems forms the basis for that assessment. Current discussions are exploring possible hardware contributions and joint technology demonstrations. No formal agreements have been announced yet. The remarks arrive amid wider international interest in sustained lunar infrastructure. Revised timelines for solar system violence connect to new evidence of the Milky Way's own dramatic past. A slowly rotating stellar halo has provided evidence that the Milky Way's spiral disk flipped more than 90 degrees in the distant past. The halo stars preserve the dynamical memory of that reorientation. Astronomers traced the motion using precise proper motion measurements across large sky surveys. The cause remains unknown, though a major merger is one leading hypothesis. Further modeling will test whether the event also rearranged the galaxy's dark matter distribution. Large-scale galactic dynamics give way to a more immediate artificial impact on the lunar surface. A SpaceX Falcon 9 upper stage is expected to strike the Moon in the coming days. The stage follows a trajectory that will end in an uncontrolled impact on the lunar surface. No payload or active systems remain aboard the hardware. The event will add another known crater to the growing catalog of artificial impacts. Lunar orbiters may attempt post-impact imaging if geometry allows. A new narrowband image of IC 5070 shows the Pelican Nebula's billowing gas clouds and fine dust filaments roughly 2,000 light-years away in Cygnus. Radiation from nearby young stars shapes the emission region into intricate forms. Double-lobed outflows mark where stellar winds have carved cavities in the surrounding material. The photograph was taken from Forest Hill, California. Continued observations will follow changes in the ionization fronts over time. Before we go, keep an eye on the next round of scheduled observations that could confirm the exomoon candidate through additional orbital data. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Nara Network. Links in the show notes. And before you go, this show is part of the Nara Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen, OmniView, a balanced daily world news briefing that takes every side seriously. Find every show free at naranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on naranetwork.com. Scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting